All right, so today we're taking a deep dive into the world of LLMs.
LLMs.
Yeah,
Yeah.
but not just your typical LLM stuff like, writing haikus or summarizing a blog post.
Right, right.
We're talking about analyzing like a whole mountain of code to find those sneaky bugs.
Oh, wow.
Or, say, summarizing a gigantic research paper, one of those that takes you like a week to get through.
Okay, yeah, I see where you're going with this.
But here's the thing, these traditional LLMs, they kind of hit a wall when you throw these super long texts at them.
Yeah, it's like they get bogged down, right?
Totally. It's like trying to stuff like a giant encyclopedia into a tiny little backpack.
Exactly. The sheer amount of data just overwhelms them, makes them slow, expensive to run.
Okay, so what's the answer?
Well, the brilliant minds over at NVIDIA,
Oh, NVIDIA.
they might have cracked the code.
Literally.
Literally. They've come up with this thing called star attention.
Star attention. Okay, I like the sound of that already.
It's all about making those LLMs way more efficient when they're dealing with, like, a fire hose of text.
Okay, so efficiency is the name of the game here.
Exactly. Instead of one massive computation, it's like, imagine breaking that problem into smaller, bite-sized pieces.
Divide and conquer, right?
You got it. That's the heart of star attention. So they've designed this two-phase process.
Two phases, okay.
First, you take the text, you split it up into these blocks,
Okay.
and then they spread those blocks out across a bunch of different machines.
So each machine is working on its own little chunk of the text.
Yeah, and they're all working in parallel.
So it's like a team effort.
It is. But here's the really cool part. Every single worker gets a copy of the very first block.
Okay, wait, so they all get like the same starting point.
Exactly. They call it the anchor block.
The anchor block.
Ah.
I like it. So it's like, is like giving each worker a little cheat sheet, like a summary of the most important stuff.
It's more like a shared reference point. Imagine, think of it like a map, right?
Okay, a map. I can picture that.
So even though each of these worker machines is exploring its own little section of the text,
Right.
they can always glance back at this shared map. They know where they are in the grand scheme of things.
Okay, so the anchor block keeps everyone on the same page, even though they're working on different parts. That's pretty clever. But hold on. How do they actually get answers from all these separate pieces? It's like they've got all these puzzle pieces, but how do they put the puzzle together?
That's where phase 2 comes in. Query encoding and token generation. This is where the magic happens.
That was mysterious.
A little bit, right. They use this fancy technique called distributed softmax.
Distributed softmax. I'm going to need you to break that down for me.
I hear you. Okay, so imagine each worker is writing a chapter of a book.
Okay.
Right, the distributed softmax. It's like the editor who comes in and seamlessly stitches all those chapters together.
Oh, okay, I see. So it's not just analyzing each piece in isolation. It's finding a way to blend all that information together.
Yeah, exactly.
Okay, so that makes sense. But the big question, the million-dollar question is, does it actually work? Like, what kind of results were we talking about here?
Oh, the results are pretty impressive. They ran star attention through the ringer, tested it on a bunch of different versions of the Llama model.
Mama, that's a popular one these days.
Right. And they even used it on some benchmarks that are specifically made to see how well models handle those really long stretches of text.
Okay, like, what kind of benchmarks?
Things like Ruler and Babylon, these are like the ultimate tests for long context understanding.
So they really put it through its paces. And
And drum roll, please. They saw speedups of up to 11 times.
11 times faster.
Wow. Compared to the best method out there before, which is called ring attention.
Okay, so that's a significant boost.
Oh, it is. But here's the best part. The accuracy. It stayed super high, almost identical to the original.
So we're talking faster and just as accurate.
You got it.
Wow.
Yeah.
So you're telling me I could, like, analyze a legal document in, like, minutes instead of hours?
Oh, yeah, absolutely.
That could be a game changer for lawyers, for researchers, for anyone working with these massive amounts of text.
Think about it like you could analyze a whole code repository in the blink of an eye. Find those bugs before they even have a chance to cause trouble.
Okay, so we've established that it's fast, it's accurate, but I gotta imagine there's got to be some trade-offs, right? Nothing's perfect.
Well, of course, there's always a balance. For example, they found that if you use larger block sizes in that first phase, you tend to get better accuracy.
Okay, so bigger blocks, better accuracy, makes sense.
But it also slows things down a bit.
So it's a trade-off.
Yeah, it's like choosing between a super high-resolution picture that takes forever to load or a smaller one that pops up right away.
I see, I see. You got to find that sweet spot.
Exactly. They found that a block size of about a quarter of the whole text length seemed to work best.
Interesting. So there's a bit of an art to tuning this thing.
There is. It's not just plug and play. You got to tweak it a little bit.
Okay, so before we get lost in all the technical details, I want to bring it back to our listener. Like, what does all this actually mean for someone who's not a computer scientist?
Right.
Why should they care about star attention? Like, what's the big takeaway?
That's a great question. I think the key thing to understand is that star attention could totally change the game for LLMs.
Okay, how so?
It could make it possible to analyze these truly massive amounts of text, but quickly and accurately, like things that were just impossible before.
Okay, give me an example. Paint me a picture.
All right, so imagine a researcher who needs to go through hundreds of scientific papers to understand the latest breakthroughs in their field.
Hundreds of papers. Oh my God.
With star attention, they could potentially do that in a fraction of the time.
So instead of spending weeks buried in research, they could actually, do their own research.
Right. Free up so much time and energy.
Okay, so that's one example. What about something a little closer to home?
Okay, how about a lawyer who has to review a super complex legal contract? With star attention, they could quickly find those key clauses, spot any potential risks.
Oh, that's a good one.
It could save their clients a ton of time and money.
Okay, so we're talking about real-world impact here. This is not just some abstract concept.
Not at all. The applications are vast. We're just scratching the surface here.
Okay, now, I'm really intrigued by this whole anchor block idea. It seems to be playing a pretty crucial role in all of this.
Oh, it is. The researchers actually did a bunch of experiments with it.
Oh, really? Like what?
They tried different positions for the anchor block. They changed what was inside it, tried to figure out what worked best.
So did they find that the position of the anchor block matters?
Surprisingly, no, not as much as you might think.
Really? Huh, I would have thought the location of that shared reference point would be super important.
You'd think so, right? But it was actually the content of the anchor block that made the biggest difference.
So it's not just about having a reference point. It's about the quality of that reference point.
Exactly.
Why do you think that is?
Well, one theory is that the anchor block acts like a mini summary.
Oh, okay.
It gives the model this concentrated dose of key information that helps it understand the whole text.
So it's like a cheat sheet, but for an AI.
Pretty much.
That's fascinating. So we've got this anchor block. It's like a mini summary. It's helping the AI understand the whole picture. But I'm curious, what about the size of the anchor block? Does that matter?
Yeah, they looked into that too. And generally they found that bigger anchor blocks led to better accuracy.
Interesting. So it's like the more information you give the AI up front, the better it can understand the rest of the text.
It seems that way.
Wow, so we've covered a lot of ground here. We've talked about the challenges of long context analysis for LLMs. We've introduced this groundbreaking new technique, star attention. And we've even started to explore its potential impact on, everything from research to law to who knows what else.
Yeah, and we've even started to peel back the layers of this mysterious anchor block.
But there's still so much more to explore. So stay tuned for the next part of our deep dive, where we'll go even deeper into the research, look at its strengths and weaknesses.
We'll even talk about the future of star attention and what it could mean for the world of AI.
It's going to be an exciting ride, so buckle up.
We'll see you there. Welcome back. Before the break, we were talking about the anchor block and, how it's like a cheat sheet for the AI.
Right. Like it gives the AI the gist of what's going on in the text.
Exactly. So let's talk about how star attention actually performs on different kinds of tasks. The researchers use this benchmark called Ruler. It's specifically designed to test how well these models can handle really long pieces of text.
Okay, so Ruler is like an obstacle course for LLMs.
Yeah, you could say that. It throws a bunch of different challenges at them. Some of them are pretty straightforward, like finding a specific piece of information in a huge document.
Like finding a needle in a haystack, but with words instead of hay.
Exactly. They call those needle in a haystack tasks. And for those tasks, star attention performs amazingly well. It's almost as accurate as using full global attention, which is really impressive considering how much faster it is.
Okay, so for tasks where it's all about finding that one crucial piece of information, star attention is a winner. What about more complex challenges? You mentioned multi-hop tracing before the break.
Right, multi-hop tracing. Those are the real head scratchers.
Okay, so break it down for me. What's so tricky about multi-hop tracing?
So it's like Imagine you're solving a mystery, right?
Okay, I like mysteries.
And the clues are scattered all over this really long document. You have to follow the trail of clues, make connections, and figure out how different pieces of information relate to each other.
So it's not just about finding a single piece of information. It's about understanding the relationships between different pieces of information.
Exactly. You have to connect the dots. And because star attention divides the text up into those separate blocks, it can sometimes miss those subtle connections between the blocks.
Okay, I see where you're going with this. So it's like trying to solve a mystery, but you only get to see one clue at a time.
Exactly. It's hard to see the big picture when you're working with those isolated chunks.
So for those multi-hop mysteries, star attention might not be the best detective on the case.
It's not that it completely fails. Even for those tougher tasks, it still manages to maintain a pretty high level of accuracy. It's just not as stellar as it is on those needle in a haystack challenges.
Gotcha. So even with those limitations, it's still a valuable tool.
Oh, absolutely.
But, if it has trouble connecting information across those blocks,
Yeah.
how does it handle tasks that require summarizing the whole text or pulling out the key insights?
That's where things get really interesting. For those tasks, star attention actually does better than the traditional method.
Wait, really?
Yeah.
That doesn't make sense. Why would dividing the text up make it better at understanding the whole thing?
It seems counterintuitive, right? But it's
Yeah.
like when you write an outline before you write an essay.
Yep.
By focusing on summarizing each section first, the model ends up with a clearer understanding of those main points. And then it can pull it all together.
So it's like star attention forces the model to think more strategically about the information.
Yeah, it's like, okay, break it down, understand each part, then build it back up.
Interesting. So it's not just about speed, it's also about encouraging a deeper level of understanding.
Right.
Okay, so we've seen how star attention performs on these different types of tasks.
Right.
But I'm curious to, peek under the hood a little bit and understand what makes it tick. The paper talks about an ablation study. What is that? And what did they learn from it?
An ablation study is basically like a science experiment where you remove different parts of the system, one at a time, and then you see how that affects the performance.
So it's like playing with the building blocks, figuring out which ones are really important.
Exactly. And one of the things they found was just how crucial the content of that anchor block is.
Right. We were just talking about that, how the position didn't seem to matter that much.
It was really surprising. They tried all sorts of different things. They used a single token repeated over and over. They used random tokens. They shuffled the tokens in the first block.
They even tried using the previous block as the anchor.
Yeah, but no matter what they did, using the actual content of that first block always worked best.
So there's something special about that first chunk of text.
There is. It's like the opening scene of a movie, Sets the stage for everything that comes after.
I love that analogy. So the anchor block isn't just a random reference point. It's like this concentrated source of key information that helps the model understand the whole story.
Exactly.
Okay, so we know the content is important. What about the size of the anchor block? Does that matter? Is bigger always better?
Well, they actually looked at that too. And generally, they found that larger anchor blocks tended to lead to better accuracy.
But hold on, didn't we say earlier that a lot of the attention seems to be focused at the beginning of the block? Wouldn't that suggest that a smaller anchor block, one that just contains those crucial bits, would be more efficient?
You would think so, right? But the data actually showed the opposite. Using a smaller anchor block actually hurt the performance.
Wow, so it's not as straightforward as it seems.
No, it's not. There must be something more to the anchor block than just managing those attention spikes.
Right, like it's playing a deeper role in shaping the model's understanding.
Exactly. And, the researchers themselves admit that they don't have a definitive answer to that question yet.
So there are still some mysteries to unravel.
Oh, absolutely. But even with those open questions, the findings of this paper are incredibly exciting.
They are. It feels like we're getting closer and closer to this future where AI can truly understand and process information like humans do.
I think so. And as we continue to explore this new territory, we're going to find even more ways to improve these models and make them even more powerful.
Speaking of which, before we move on, I want to talk about the potential for combining star attention with other optimization techniques. Like the paper mentions things like KV cache compression. What's that all about?
Oh, yeah, KV cache compression. That's another really cool idea. It's basically about shrinking the amount of information that needs to be stored in memory.
So it's like packing for a trip and only bringing the essentials.
Exactly.
You're making the data more compact, more efficient, and if you combine that, with the speed of star attention.
It's like a double whammy of efficiency. You get a system that's both super fast and uses less memory.
It's like having a race car that also gets amazing gas mileage.
Exactly. And that opens up a whole new world of possibilities. Imagine being able to analyze real-time data streams.
Whoa, like social media or sensor data.
Yeah, things that are constantly changing.
And you could do it all with the speed and accuracy of star attention, boosted by KV cache compression.
Exactly.
That's incredible.
Yeah. And, I think it highlights a really important point. Star attention isn't just a standalone solution. It's like a building block that you can use to create even more powerful AI systems.
It's like we've discovered a new element, and now we're figuring out all the amazing things we can do with it.
I love that analogy. It really captures the spirit of what's happening in AI right now. It's all about innovation and exploration.
Well, on that note of boundless potential, I think it's time to wrap things up and move on to the final part of our deep dive.
Yeah, let's do it. We'll leave our listeners with some final thoughts to ponder.
Okay, so we've explored this star attention, seen how it works, what it's good at, maybe not so good at.
We've really gone deep, haven't we? But I think it's important to remember, with any new research like this, we got to stay grounded,
Keep our expectations in check.
Exactly. These results, they're impressive, no doubt. But this is still early days.
Right. Things could change as it gets, out there in the real world.
Absolutely. Like that old saying, don't count your chickens.
Before they hatch, yeah. We've seen the potential, but we got to see it in action.
I like that. And the researchers themselves, even they say, more research is needed.
They're not getting carried away.
No. Especially with those limitations, like those multi-hop tasks.
Right. Still some work to do there.
Even if star attention doesn't magically solve everything.
Yeah.
It's a huge step forward, shows how creative these AI researchers are.
It's amazing how fast this field is moving, right?
It is. What with science fiction is becoming like our everyday reality.
And as these LLMs get even more powerful,
Techniques like this, they're going to be essential.
to keep pushing the boundaries.
Like imagine we're building this rocket ship to explore language.
Oh, I like that.
Star attention, it's one of the engines propelling us forward.
Okay, before we wrap up completely, I want to circle back to the tasks that star attention is really good at.
Right.
Talked about needle in a haystack.
Finding that one key piece of information.
Right. And multi-hop tracing, where it's still got some room to grow.
Yeah.
But what about those tasks, like summarizing a whole long document or pulling out the most important insights?
Those are the ones people get excited about. For good reason. Think about it. Summarizing a research paper instantly. Or grabbing the key parts of a legal contract.
That's what we all want, right? To save time, get to the good stuff. So how does star attention do on those?
Remember how we were saying breaking the text into chunks actually helps the model summarize better?
Yeah, it was counterintuitive.
It is. But by forcing the model to summarize each section, it gets those main points. Then it's easier to bring it all together.
So it's like a team of super smart note takers.
Right. Each one focused on their part.
And then someone comes in and makes it into one cohesive summary.
Perfect analogy. And the data shows it. Star attention beats the traditional method.
For summarizing and finding those key insights.
More efficient and more accurate. Can't beat that.
So maybe not the best detective for every mystery.
True.
But when it comes to summarizing, getting the gist of these giant texts.
Star attention is a star performer.
It really is. And as research continues,
We're going to see even more improvements, I bet. Maybe even solve some of those limitations.
it's an exciting time to be following AI, that's for sure.
So much potential for good in so many areas.
And it's not just about the tech itself, right?
It's bigger than that. It's this whole movement towards making AI more powerful, but also more efficient, more accessible to everyone.
Exactly. So as we wrap up this deep dive on star attention,
What's the one thing we want our listeners to take away?
this. Imagine a world where anyone, no matter their tech skills, can use AI to analyze mountains of information, get those key insights, make better decisions.
A world where knowledge is truly democratized.
Exactly. So stay curious, stay engaged. This field of AI, it's only getting more exciting. Until next time.
See you then.